Good morning. I'm here at the LOEWS Hotel in Hollywood on the island barges into Dolby. I'm on the 11th floor, and this morning we're continuing with some Fourier Transform. As we have left off yesterday, we said that we would do the y equals e to the t, or f of t equals e to the t. So if f of t is equal now to e to the t, remember yesterday we did f of t equals the e. Then we say now that the Fourier transform, let's do that fancy sort of a f, is equal to f of t e to the minus j omega t dt. And this will be integrated from infinity to minus infinity. So let's do it now. We say now that Fourier transform, sometimes written like so, it's sort of a fancier, is equal now to the integral of e to the t, e to the minus j omega t dt. And this is equal now to the integral minus infinity to plus infinity now of e, and we factor out that to get j omega t into j omega into t dt. And that's equal now to 1 over 1 minus j omega e to the 1 minus j omega t that. And henceforth, for me, it would be an operation of integration. But we're just here trying to show you that the formula is you multiply the f of t by e to the minus j omega t, and you integrate from minus infinity to plus infinity, and that would be the Fourier transform. And for this, we could also draw, it's useful to draw a sketch of the function f of t, and it would be looking something like so. With my this is the function f of t equals e to the t. So from henceforth, it would be an operation of integration. Okay, all right, let's quickly do some expansion here. And it'd be useful that we're going to use the expansion of e to the x. And we see now that e to the x would be equal to e to the 0 plus e to the 1 over 1 factorial plus e squared over 2 factorial plus e cubed over 3 factorial plus e to the 4th over 4 factorial plus e to the 5th over 5 factorial plus e to the 6 over 6 factorial plus e to the 7 over 7 factorial, on and on and on, e to the n over n factorial. Also want to do an expansion of sine x, and we say sine x is an odd function, so the expansion of sine x would now be equal now to minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7 over 7 factorial plus x to the 9 over 9 factorial minus x to the 11 over 11 factorial plus x to the 13 over 13 factorial minus x to the 15 over 15 factorial, on and on and on. An odd function. And for cosine x, expansion of cosine x, that would be called, cosine x is what we call an even function. And that will be equal now to 1, which is x to the 0, minus x squared over 2 factorial, plus x to the 4th over 4 factorial, minus x to the 6 over 6 factorial, plus x to the 8 over 8 factorial, minus x to the 10 over 10 factorial, plus x to the 12 over 12 factorial, minus x to the 14 over 14 factorial, on and on and on. We could also do similarly for hyperbolic function sinh x and hyperbolic cos x. And we could also useful to find it. For tan x expansion, we could say tan x is equal to sine x over cosine x. So whatever it is, we'd have x to the 1 over x to the 0 minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7 over 7 factorial. That's for the sine x. And it's all over cosine x, which is the x to the 1, the 0, minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus x to the 8 over 8 factorial. That's one way of doing it, which is more complicated. We just write down the expansion of cos x, and likewise for hyperbolic tangent x. So you have done some useful expansion here that we'll be using. Expansion of e to the x, expansion of sine x, cosine x, tan x, sinh x, cos x, and hyperbolic tangent x. Let's take a break and we'll come back to do some AMG 5×12 matrix, and we'll continue with some advanced calculus.